But there are a couple of other reasons why we use this framework, because it can be used in a couple of other ways in the planning process. So this is the City of Edmonton standard planning process. We move from our strategic plans on the left to the development and building permits on the right. Around our strategic plans, 1993, we had one polygon. This is natural area Northwest 384. It's actually our only, it protects our only sand dune in Edmonton. And at the neighborhood structure plan, though, when we incorporated the uPLVI, we had about 5 polygons. I didn't pull out the agricultural polygons, but there were about 5 there. And now we're doing natural area management planning. And now we've got about 16 polygons that are pulled out of that natural area. And as you go through the development process, you can get higher and higher resolution of data based on your needs. We didn't have the money to do it at the strategic planning level. We do now, and it's important because we have to manage these things appropriately. So we have a higher and higher resolution through the planning process that you can start focusing on where you want your efforts to go, your mapping efforts. So another way to do is the city has a number of international commitments. We signed on in 2010 to the Convention on Biological Diversity. It's for countries to sign on, and Canada signed on saying we're going to protect 10 to 17% of our natural areas or our major eco-sites. Now, urban municipalities aren't expected to follow that because we are supposed to densify and get a lot of population into our boundaries, but you can see that Edmonton's not doing so bad. I mean, we've protected about 50% of our major eco-site classes. And so as we move forward with planning, we can try to identify, well, where are those wetlands and those the modal areas, and those are areas that are driven by soil type. And so we'll understand the value of that as we go through the planning process. Wetlands. We've never before had a citywide inventory of our wetlands. Now these are only wetlands over 0.5 hectares, but you find out very quickly that 25% of Edmonton's remaining wetlands are in that little corner in the southeast called Dakota. And if people haven't heard of it, I'm surprised, because it's causing a lot of headaches because there's a lot of wetlands there. And it's understandable why there are, because of the natural topography in that area. So now future use, because this is linked into the city's provincial framework, it's just a higher resolution. The reason why we wanted to do this is because land use planning regionally is really important, and it's something that municipalities have never been able to do. I've looked at Strathcona's data, St. Albert's data, and it's all good data, but we're all using different terms. We're all using different resolution. And so here's the provincial, the primary land vegetation inventory of the province started in 2013. This is how much of the province they've mapped out, understanding that a lot of the green area is mapped out through the Alberta Vegetation Inventory, which the PLVI is actually linked into. But you can see, if we start thinking about regional planning using the land use framework, we've got some gaps to fill in. And we just filled in the gap around Edmonton and 3.2 kilometer buffer. And so if we all start using this, we can start integrating our planning and talking the same language. Right now I just got a call from our provincial colleague, and he's working to incorporate our data into his. So current use, this work, the primary land and vegetation inventory, has actually been used by a lot of programs in the city already, even though it's not officially released publicly, which it will be. Discharge improvement zones, various creek studies and sub-watershed studies to help outline kind of the upland habitat, low impact design location study, and most exciting is the greenhouse gas emissions calculations. So our first use of uPLVI was in 2013, but with this, when the mayor signed on to the Paris Accords, we needed to upgrade our systems around how we calculate emissions, global greenhouse gas emissions. And so we updated our uPLVI to 2015, and we retrospectively updated it to 2005. And so now for the last 10 years, we can actually find how land use changed, not through zoning, but what actually is on the ground, what's occurred in the last 10 years. And what you can see is that close to 500 hectares of forests were converted to residential and industrial. Close to, 4,600 hectares of agricultural land were converted into industrial and residential. Before, we'd have to kind of pull it out and assume our zoning was good, but a lot of things that are zoned as industrial, for example, still has a lot of vegetated cover on it, even some natural areas. So now we actually know what is on the land and not just what's in the zoning. So, I want to put in a plug. The city just the other day they won their application to host the March 2018 IPCC Cities and Climate Change Science Conference. So everybody keep your eyes open. I think APPI would be well placed to have a strong showing there. And it's basically about what cities can do around climate change and how climate change is going to impact cities, and some of our planning ideas and how we have to evolve with the times to understand climate change basically impacts on urban areas. So another cool thing, which I never thought, I was just flown to Barcelona, Spain, because our data, the European Space Agency has a number of satellite imagery, and remember I said we tried to do this in 2010, but we went this route instead. Well, the European Space Agency is trying to use their satellite data to map out natural areas, and they needed a city with a solid database to verify and validate their work. And so the City of Edmonton was chosen because of this work. I don't know of another municipality that has this type of mapping information. And then we've obviously used this information for a number of city plans. In particular, I don't know if people have heard of BREEVE, Edmonton's Green Network Strategy. This is kind of some baseline data in that. We've got a lot of River Valley site planning, including the new ribbon of green that's moving forward. This is being instrumental in that. But after all of that, and I'm all a keener, I'm a mapping keener, a little bit of geek around the ecology, I was like, great, now the city has a tool. Everybody's going to be using it. It's going to be wonderful. And people look at me and go, what? Ecosite? What? What are you talking about? So I learned very quickly that the city actually had to use this information and adapt it in a way so that planners can use it. Maybe not be the experts in ecosite analysis and not be the experts in which forest stands are in breakup, but to be able to use it and understand how it can be used in land use planning. So this is where the Environmental Sensitivity Project comes in. It was our attempt to basically provide a strong environmental evidence base for continued improvement of planning in Edmonton. Citywide in scope, obviously our uPLVI is based on the citywide approach, and it incorporates ecological connectivity, natural asset assessments, and planning constraints. And so let me walk you through this just quickly. This is the basic methodology. It's an additive model. You figure out what all your natural assets are, so whether it be wildlife habitat or rare species, unique landforms, unique vegetation communities. You figure out what the threats are on those, so you subtract the threats, and then you add constraints. Are there floodways? Are there unstable slopes? Are you in areas that probably will need to have massive engineering feats in order to protect something from sliding down the slope? And then you add those together and you get environmental sensitivity classes that hopefully planners will like to use and understand. So this is the existing data, and the ones in red is basically the ones that are derived from the uPLVI, basically saying that this work couldn't have been done without us doing this foundational framework. We also had a number of our zoning classifications: environmental reserve, provincial protected areas, rare species from provincial databases, because the city actually doesn't have its own database. That's something that we're working on through, I know a lot of people have probably been involved in River Valley bylaw projects, and so we're going to start gleaning that information so we can have our own database, flood zones, which are mapped out by the province, and historical resources, which are also mapped out by the province. Now, the new data that we developed is, so as I said, the resolution of the uPLVI is based on the money that you have at the time. So we couldn't go into wetland areas of less than 0.5 hectares. So using basically our newly acquired LiDAR and our 4-band imagery, we're able to automate pulling out wetlands that are less than 0.05 hectares. We did our stream mapping, desktop-based ravine geomorphic limit, unique landforms, and a number of other things. The one thing I wanted to talk about, though, is moving all of our mapping systems up until now have really been based on, there's been no connectivity incorporated in them. And so we had to find a way to make sure that the data sets that we had could help us map out or model where wildlife connectivity, which is also, when I say wildlife connectivity, it also talks about nutrient cycling, nutrient exchange, genetic flow, all of these things. When I say connectivity, I'm talking about all of these items. So we don't have the money to go out and put wildlife cameras all over the place. We don't have the money to go out and assess nutrient flow through our ecological network. But we do have some of the newer technology developed by, not technology, software developed by the academic community can help us identify where those potential zones are. So this is where we get into Ohm's law of circuit flow, and using the principles of circuit theory, we basically create a map with all of our uPLVI data and all of our various systems about, and when we look at particular wildlife species. So for this is a chickadee. This is for chickadees. So we looked at the landscape, and the University of Alberta has a lot of good researchers who are doing work on songbirds. And so we basically know songbirds don't like to cross roads that are greater than 25 meters. They very rarely go through grasslands. They like tree cover. All of these things, when piled on together, illustrate a resistance map across the city of chickadees moving through the system. We did the same thing for coyotes. Now, why chickadees and coyotes? People don't like coyotes. It's because it's the only species we have information on. And coyotes are representative of medium mammals, and in some cases, large mammals like deer and moose. So anyways, we created a resistance map for how chickadees and how coyotes might move through the system. And you send a charge through the system. You send a charge through the resistance map. And those areas that are red are the areas where the voltage gets constrained and it moves faster. And so when you relate that to wildlife movement or connectivity metrics, that means that those are areas of constricted passage, areas that could, if improved upon, could increase your connectivity through your whole system. So, and that's what we did here for chickadees. We did kind of little neighborhood analysis where we just basically showed how chickadees move through the city. And it was really fascinating that there are a lot of barriers for chickadees, but they get around. And so when we talk about chickadees, it's really about songbirds. It's avian use of the City of Edmonton. And where are the corridors that even individual citizens, if they see that they're on this corridor, they can go, hey, I could plant an extra tree. I can. So it's really providing tools for people to go, I don't necessarily need to know the details of what circuit theory is, but what it tells me is I can actually have an impact in my neighborhood. So just a couple of the other things. I'm going to show you some of the assets and some of the constraints and how it ends up hopefully being a tool that planners will be able to use. So this is habitat connectivity and rare species. You probably can't see a lot on the big screen. So here's Terwilliger Park as an example. You might have a hard time seeing the little pink areas, but that's arboreal connectivity, so those are your birds. The dark brown is where arboreal connectivity and terrestrial connectivity overlap. And so you can see Terwilliger is mostly, it's difficult for arboreal because there's a lot of open fields. And so if a field is greater than 25 meters, it's likely that the arboreal critters are flying around the edge. But anyways, and then all the little yellow dots are all of the records, the wildlife species records from the province. Now here's an example of upland and aquatic habitat. And so here you can see we've mapped out the river as well. The yellow areas in the river are runs, and the purple areas are flats, and other areas we've got riffles. And so basically important habitat that's within the river for fish. And then you can obviously see the upland habitat in Terwilliger really popping out. And this isn't depending on wildlife species, it's depending on what's native, what's the density, those types of things. Now, unique landforms and vegetation, just a couple of things I want to point out. We've never actually had the Beaver Hills Moraine mapped out, and this led to the big surprise by everybody that 25% of our wetlands are in that area. And so we've got that mapped out now. And remember I told you about Northwest 384, the area that has our only sand dune, our only protected sand dune. So this whole area right here is the Devon Sand Dunes. It just touches upon the southwest corner of Edmonton, and our only protected sand dune is this little brown one right here. Right there. That's our only protected sand dune. So it's again a unique geological feature that we never actually considered in our land use planning. And we actually happened to just pick it up because we were picking up the white birch tree stand that's right to the south of it. So it was actually the environmental community that said, city, you just protected the first sand dune as well. So then you talk about planning constraints. So we talked about our assets, then you add on the planning constraints. This is something that's been a hot topic, is our areas of floodway and flood fringe and what that means to development. And the province has new policies around, not developing in the floodway. So again, more information on the planning constraints. Then cultural constraints in protected areas. The red and yellow are the protected areas. And the cultural constraints were a difficult one. That's kind of proprietary information that's not often let out. And so what we have individual sites, but what we've only mapped out here is the large kind of quarter section areas people are probably familiar with that you can get for free from Alberta Heritage. And it's basically showing generally where you need to keep your eye open for cultural constraints. Now ideally, you add all those threats, or as assets, threats, and planning constraints together, and you get your environmental sensitivity map that is actually being used already in the city for doing some site planning. Such as in Dawson Creek, if people have heard about that plan, they've identified a wildlife corridor that they're restoring, and a potential, and this is starting to be used to help do individual site planning and to really get into the details. So if you look at this, that's Terwilliger Park again, and you can see the dark green is the extreme sensitivity. Those are generally where you've got not only your steep slopes, but you've got important assets around ecological network and connectivity. So the best management practices there are, do your site planning, get to know what's there. Generally, you probably don't want to put in a lot of infrastructure there because there's steep slopes and there's high ecological sensitivity. And then it goes all the way down to yellow. And the yellow is often street trees. That's the value. But this is where we have to understand that the city can't do it by itself. We can't protect a whole ecological network. We don't have the tools in place. But we do have a citizenry that in 2001 told us, you guys aren't doing it right. You got to do better. And so now we're saying, well, do you know what? We all have to do better. And here's your opportunity. If you're in those areas of yellow or orange, you've got some great opportunities to help with connectivity and to help green up Edmonton. So, and then future use, we talked a little bit about identifying the pinch points in the system, restoring, and this is what's being done in the Dawson Park Master Plan right now. Now, people have probably heard about BREATHE, and so this is where we're talking about integrated land use planning. We just finished the uPLVI, it feels like, and we just finished the environmental sensitivities. Already we're looking for the future and where we can take our data next. So the purpose of BREATHE, it was again a citywide strategy which fits in nicely with our environmental sensitivities mapping and our uPLVI. Now their shift, we did it back in 2007 around the ecological network. The shift here is that the whole open space planning system needs to move to a network approach, which the ecological network is already perfectly suited to fulfill or to just jump on that bandwagon. And BREATHE, if people noticed, was heavily focused on the systems that our open space planning gives to us. Now, it's divided into ecology, celebration, and wellness, but these all kind of mix together. But an example of some of the services that the ecology provides us are like water management, what I had talked about earlier, climate regulation I didn't even touch upon, risk mitigation, food production, and then you've got your celebration and your wellness around recreation and mental health and well-being, which obviously overlays with the natural areas and the values of those. And so in the future, we're actually starting to talk about, okay, we've got our transportation network, we've got our drainage network. We know the cost of those things and the benefits they provide to citizens. Can we do something similar for our natural assets? Can we understand the value of ecosystem services and how it can all interrelate into a triple bottom line approach, where you're talking about the economy, social, and environmental aspects? This is all new stuff, so if anybody has any solutions, I would love to hear it, because I got a lot of work to do on that. So we found this out. Singapore, I don't know if people know, Singapore once branded itself as having a park in the city. A big, beautiful park. They've got like green roofs galore. But now they've rebranded themselves to be the city in the park because they have so much green space that they've incorporated into their urban system. And so this model is actually from them, and it was really fascinating for us to compare where the City of Edmonton is. So they moved from isolated protected areas just like we did, from 1907, which was when our first park was, to 1993. And then we actually started talking about, okay, let's catalog, let's find out where all of our other natural areas. That's 1993, that first spatial database that you saw. And then the public actually stood up and said, you guys aren't doing enough. You need to get people allocated in the city to plan out these areas. And that's in 2002. We got our first kind of the conservation coordinator, Grant Purcell. I don't know if people know Grant. And so there was a governance aspect. And then in 2007, there was a paradigm shift from that single site approach to the more ecological network approach. And now the exciting thing is that we're on the precipice of actually moving to the next and ultimate phase, which is a multifunctional landscape planning approach that looks at the whole network, transportation, drainage, open space, so that we can become a biodiverse city, is what Singapore called it. What somebody else calls it is actually a biophilic city. And in 2016, Edmonton was the first of only 2 Canadian cities that became a biophilic city, or at least, and the goals are aspirational. We're not a biophilic city right now, but the goal is that we're going to be a city abundant with nature, and repair and restore and creatively insert nature wherever possible. And council approved this in 2016, and we had this big hubbub at the library, if anybody knew. And so moving forward, we've got some big goals to attain, and it's really going to take more than just city administration. And that's why we developed these tools, so that everybody can have a role and everybody can see where their little 100-meter square area of the city can support if they want to. So that was that. Thank you very much for your attention. I hope you enjoyed it. Now understand a little bit of where the city's going with our mapping, our natural asset mapping.